Factorizing is a very common exam question. I think almost every examination has a question on factorizing. Now, there are different ways of factorizing depending on the question that you have. There is factorizing by grouping, factorizing difference of two squares, factorizing of a quadratic expression, and so on. So, but now I want us to look at how do we factorize a simpler algebraic expression. How do we factorize a simpler algebraic expression? Let's take, for example, an expression like 5x plus 25. 5x plus 25. So to factorize this, it means we have to look for the factor of 5 and 25. We have to look for a factor of 5 and 25, and should be the highest common factor. And I think by now you know what a factor is, a number that can divide 5 and a number that can divide 25. And then after finding that factor, you take it outside the brackets. And then after taking it outside the brackets, you take your entire expression and divide it by what is outside the brackets. Then you simplify. This is what I mean. We look for a factor of 5 and 25, and that factor is 5. And then from there, we take our entire expression, which is 5x plus 25, and divide it by everything that is outside the brackets, which is 5. Then simplify what is inside the brackets. So simplifying what is inside the brackets, we now get 5. The numerator and denominator are the same, so they cancel out. So it means we are left with an x there. Then plus 25 divided by 5, we get a 5. So it means our final answer is 5x plus 5. Then I'll do another example. We do the same thing. The concept is the same. Then it's just that we are now doing a different question. So let's look at 10y plus 2x. We do the same thing. We start off by looking for factors for the numbers that we have in our expression. We start off by looking for the highest common factor of the numbers that we have in our expression. So it means we are looking for the highest common factor of 10 and 2. What is the highest number that can divide 10 and divide 2? So that number is 2. So from there, we take our entire expression and divide it by our factor, or we divide it by everything that is outside the brackets. And doing that, we get 2. 10 divided by 2 gives us a 5. Then, of course, our y is going to be there. Then plus the numerator and the denominator are the same, so they cancel out. So it means we are now left with an x that side. So it means our final answer is 2, 5y plus x. Then I'll do another example, example number 3. Let's take, for example, 9x minus 18xy. Now, this one is a little bit different. It's a little bit different in that we now have common variables in both terms. We now have common variables in both terms. For example, we have x here and we have x here. But the way we do it is just the same. Let's start off by looking for a factor of 9 and 18. A number that can divide 9 and a number that can divide 18 as well. So that number is 9. So we put it here. Then now we have, because we have both variables, we have the same variables in both terms. It means we're going to take that variable outside the brackets. Because we have x here and then we have x here, so it means we have to take the x outside the bracket. So a variable that is common or that is present in both terms has to go outside the brackets. Then we have a y here, but we don't have a y here. So it means we can't take y outside the bracket. So we only take the variable outside the brackets if it is common or if it is present in both terms. Then from there, we do the same thing that we have been doing. We take our entire expression and divide it by everything that is outside the bracket. This time, everything that is outside the brackets, it's 9x. So we divide everything by 9x. Then from there, we simplify everything that is inside the brackets. What is outside the brackets doesn't change. It will always be like that. But what is inside the brackets, it is going to change because you are now simplifying what is inside the bracket. So 9 divided by 9, we get a 1. The x here is going to cancel the x here there because the numerator and the denominator are the same. So they will cancel out. Then from there, we have 18 divided by 9. 18 divided by 9 is 2. Then the same thing here is going to happen. The x in the numerator is going to cancel the x in the denominator. And then, of course, we are left with a y. So that's our final answer. Then let's do example number 4. And in example number 4, let's take 2x squared minus 4x. We do the same thing. First, let's look for a factor of 2 and 4. Let's look for a factor of 2 and 4. And that factor is 2. Then let's check our variables. We have an x here, and then we have an x there. So it means an x should go outside the brackets. Then from there, we take our entire expression and divide it by everything that is outside the brackets. Then we can now simplify everything that is inside the bracket. 2 divided by 2 is a 1. Then now we have x squared divided by x. We have x squared divided by x. X squared divided by x gives us an x. Because from the law of indices, if you have an index, because from the law of indices, if you have an index here that has the same base as the index here, so it means we are going to subtract our powers. The law of indices says if the bases are the same, we subtract the power. So it means we're going to have 2 minus 1. So we have a 1 there. And then from the law of indices again, it says everything raised to the power 1 remains the same. So which means in this case, if you take x and raise it to the power 1, so you are still going to get an x. So that is why we have an x here. Then we continue and simplify our expression. 4 divided by 2, we get a 2. Then the same thing happens here. The numerator and the denominator are the same. So it means they are going to cancel out. Then it means we can now close brackets. And then that gives our final answer as 2x, x minus 2. So remember what I said earlier. You can remove this one, because mathematically we don't write coefficients of 1, but you just have to know that there is a coefficient of 1 there. Then let's do example number 5. Example number 5, we now have 3x squared, 3x cubed rather, 3x cubed minus 2x squared. Now, we do the same thing. We look for a factor of 3 and 2. We look for a factor of 3 and 2. So there is no factor of 3 and 2. We don't have a number that can divide 3 and divide 2, except 1. So, but we don't write the 1, so we can just leave that out. So then we now go to our variables. We have x to the power 3 here, and then we have x to the power 2 there. So it means in this case, what goes outside the brackets is going to be x squared. It is going to be x squared, not x. Now, when we get here, what goes outside the brackets, it should be the one that has the lowest power. The lowest power that we have there, it's power 2. And then we also have power 3. But what goes outside the bracket should be the lowest power in what we have there. So you can't write x alone because we don't have just an x there. Because if you write x, x has the power of 1. But I'm saying you take outside the brackets what has the lowest power. And in that case, it's x to the power 2. Then after doing that, we do the same thing that we have been doing. We take our entire expression and divide it by everything that is outside the bracket. So in this case, we are dividing by x2, we are dividing by x2, then we can simplify everything that is inside the bracket. So simplifying, we now get x squared. So the 3 is going to remain there because there's nothing that we are dividing it with, or we are dividing it with the 1. There's a 1 there, but the 1 is not written. So 3 divided by 1 gives us a 3. Then from there, we have x to the power 3 divided by x to the power 2. X to the power 3 divided by x to the power 2. From what I just did, we now have indices. So, and I said the law of indices says if the bases are the same, you subtract the powers. So it means our answer is still going to have the same base, but then we are subtracting the powers. 3 minus 2, it gives us a 1. And I just said everything that is raised to the power 1 remains the same. So it means we have an x there. So which means we have an x here. Then minus, there's a 1 here, but the 1 is not written. So it means it's 2 divided by 1. We get a 2. Then your numerator and the denominator are going to cancel out because they are the same. So it means your final answer becomes that. So let's do example number 6. Let's do example number 6. 4x to the power 4 minus x to the power 2. We do the same thing. There's a 1 here, but the 1 is not written. So you look for a factor of 4 and 1. What is the highest number that can divide the 4 and the highest number that can divide the 1? So that number is 1. So we don't have to write it. So we can just leave it out. Then now let's look at our variables. Let's now look at our variables. We now have x to the power 4 and x to the power 2. So it means what goes outside the brackets is going to be x to the power 2. Because I said you take the lowest power, an index that has the lowest power, you take it outside the brackets. Then from there, we do the same thing that we have been doing. We take our entire expression and divide it by everything that is outside the brackets. Then simplify everything that is inside the brackets. So we are now going to have x2. Then there's a 1 here again, but the 1 is not written. So it means we have 4 divided by 1. We get a 4. Then we now have x to the power 4 divided by x to the power 2. X to the power 4 divided by x to the power 2. We have indices there. So the same thing that I've been doing, I'm saying our bases are the same. So it means our final answer is going to have the same base. And then the power, we subtract the power. the powers. So it means we're going to have a 2 there. So it means we have an x squared there. Then we have a 1 here, and then we have a 1 here. So 1 divided by 1, we get a 1. Then x squared cancels the x squared because they are like terms. I mean, because the numerator and the denominator are the same, so they cancel out. So it means our final answer is going to be like that. So we do the same thing. We do the same thing. The concept is the same, but you are going to get different set of questions, but we do the same thing all the time. Even if I can do the next example, which is 16a squared b squared plus 18ab. We do the same thing. We start off by looking for the highest common factor of 16 and 18. The highest common factor of 16 and 18. And that factor is, okay, let me see. Is it 2? 2, yes. Yes, it's 2. So I write my 2 here. Then after that, I now go and check my variables. So I have an a here. I have an a here. I have an a here. Here I have a squared. Here I have a to the power 1. So it means I take the one with the lowest power outside. And the one with the lowest power is the one that has a power of 1, and it's a. And I do the same thing for the next variable, which is b. So I take the one with the smallest power outside the bracket. The one with the smallest power is b. Then from there, I do the same thing. I take my entire expression, 16a squared b squared plus 18ab. Then I divide it by everything that is outside the brackets, which is 2ab. Divide by 2ab. Then I simplify everything that is inside the brackets. Then simplifying everything that is inside the brackets, I get what is outside the brackets. Remember, it doesn't change. It stays the same. So it means inside the brackets, I now have 16 divided by 2. 16 divided by 2 is 8. Then a squared divided by a, I get an a. B squared divided by b, I get a b. Then I go this side. 18 divided by 2. 18 divided by 2 is a 9. Then a divided by a, it's a 1. B divided by b, it's a 1. Or if I do it like I've been doing it, the numerator cancels the denominator. The numerator cancels the denominator because they're the same. So then you now close your brackets. So it means that's your final answer there. I'll do another example. I'm doing a lot of examples so that you can understand. I'm doing a lot of examples so that you can understand. So the next example that I'm going to do is 50 c squared d minus 60 c d squared plus 70 c to the power 3 d to the power 3. So we do the same thing. We do the same thing. So like I've been saying, the concept is the same. The concept is the same. What changes is the question. I always tell students that from one concept, you can have a million questions. From just one concept, we can come up with a million questions because the concept doesn't change. It will always be like that. But the question is going to change. Questions are going to be different all the time. But we just do the same thing. So we look for a factor of 50 60, and 70. The highest number that can divide 50, that can divide 60, and that can divide 70. And that number is 10. We put it there. Then from there, we check our variables. We check our variables. So we have a c squared here. We have a c here. We have a c to the power 3 there. So I said we take the one with the lowest power outside the bracket. And that one is c. Then from there, we check the next variables to see if they appear in all the terms. So we have a d here. We have a d squared here. We have a d to the power 3 there. So it means the d has to go outside the brackets as well. Then after doing that, we take our entire expression and divide it by everything that is outside the brackets. We take our entire expression and divide it by everything that is outside the bracket. So we divide everything by 10 CD, divide by 10 CD there, divide by 10 CD there. Then from there, simplify what is inside the bracket. So what is outside the bracket, I said, it doesn't change. What is outside the bracket, it doesn't change. So what changes is what is inside the bracket. So 50 divided by 10, it gives us a 5. C squared divided by C, we get a C. The D cancels the D. The D cancels the D because the numerator and the denominator are the same. So we then move on to 60 divided by 10, we get a 6. The C cancels the C because they are the same. Then D squared divided by D, we get a D. From the law of indices, what I've been doing, then plus 70 divided by 10, we get a 7. Then we have C cubed divided by C, we're going to have C squared. Then D cubed divided by D, we are going to get D squared. And that's our final answer right there. So I'll do example number 9. I'll then do example number 9. I'll stop at example number 10. I believe that will be sufficient for you now to know how this factorizing go about. So example number 9, 7xy plus 14y minus 21x. We do the same thing. We look for a factor of 7, 14, and 21. And that factor is 7. We put it outside the brackets. Then we check our variables. We then check our variables. We have x here, but we don't have x here. So that means the x doesn't go outside the bracket. Just because we don't have it here, so it means we are not taking it outside the bracket. So then we go and check the next variable. We have a y here, we have a y here, but we don't have a y here. So it means the y is not going outside the brackets as well, because it is not present in all the terms. So that means only 7 is going to go outside the brackets. Then we take the entire expression and divide it by what is outside the brackets, which is 7. We divide everything by 7, we divide everything by 7. Then we simplify what is inside the brackets. So it means we're going to have the 7 cancels the 7. So it means here we are left with an xy. 14 divided by 7, we get a 2. And then we are left with a y there. 21 divided by 7, we get a 3. Then we are left with an x there. So that's what we get. Then the last example, we do the same thing. We now have 8bc plus 40b plus 24 BD. We do the same thing. Start off by looking for a factor of 8, 40, and 24. A number that can divide 8, a number that can divide 40, and a number that can divide 24. So that number is 8. So I'm going to write it there. Oh, sorry. Before I open the brackets, then I have to check my variables. I have have variable B here. Then I have variable B here. So I have a B here. So it means a B has to go outside the brackets as well. Then check the next variables to see if they are there in all the terms. So we have a C here, but we don't have a C here. We don't have a C here. So it means the C is not going outside the brackets. Then check the other variables. The other variable that we have is D here, but D is not present in here and there. So it means we can leave out D. Then it means we can now open up our brackets, take our entire expression and divide it by everything that is outside the brackets. You divide everything by 8b, divide by 8b, divide by 8b. Then we simplify. What is outside the brackets remains the same. Then we simplify inside the brackets. The 8 cancels the 8. The b cancels the b because the numerator and the denominator are the same, so they are canceling out. So it means here we are left with a C. Then we have 40 divided by 8. 40 divided by 8 gives us a 5. So the B cancels the B. Then we have 24 divided by 8. That gives us a 3. Then the B cancels the B. Then we are left with a T. So that's what we get as the final answer.